Okay. This is problem number 8, the last of the exercises, and perhaps the most important of all the exercises. This involves Boltzmann's law, which I will be doing a separate presentation on Boltzmann's law, but not until we've covered this aspect. All of the exercises we've been doing so far have the effect of demystifying Boltzmann's law. And so I'm asking you the following questions. A, what is the fraction with kinetic energy E sub k greater than or equal to 3 k sub bt, where k sub b refers to Boltzmann's constant times the temperature, and E sub k refers to the kinetic energy. And that's the first part. Then part B, 10% of the molecules have E sub k greater than or equal to what energy? And then C is going to be what percent of the molecules have E 10% value, the one we've found above, less than or equal to E sub k, which is in fact less than or equal to E 3 kBt. Well, this is, I'll explain this in a little while, but basically we found this in part A. We found this in part B, so I want to know what percent of the molecules fall between these two ranges. These are the types of questions that can easily be answered with Boltzmann's law and Boltzmann's factor. Okay. So the first one, what is the fraction with kinetic energy Ek greater than kBt? And that is given by the Boltzmann term, e to the minus ek over kBt is equal to e to the minus, because we set this equal 3 kBt over kBt, and that is simply e to the minus 3, which we now substitute in the identity for e, 10 to the 0.434 to the minus 3. And then I have to go over on my scratch paper and go minus 0.434 times minus 3. 4 times 3 is 12. 3 times 3 is 9. 10. 4 times 3 is 12. 13. 1.302 equals 10 to the minus 1.302. And now I have to convert this to the scientific notation in order to get the fraction, or express it as a fraction, because I'm asking what the fraction is. I want a decimal fraction. So this is the simple techniques we already know. 1.302, I'm going to take a 0.302, and that's going to be 1.000, and that's an 8. This is a 9. This is a 698. So it's going to be equal to 10 to the 0.698 times 10 to the minus 2. Okay? This adds together to get this. Okay, now I've got a number that I can get pretty close to, because 0.699 is what? 5. So that is equal to 5.0 times 10 to the minus 2 equals 0.05. So that's the fraction. And that means 5% of the molecules are going to have, for all temperatures, 5% of the molecules are going to have an energy greater than 3 times kBa, kV times T in Boltzmann factor. Now, for another version of the same thing, we have part B. 10% of the molecules have EK greater than or equal to what energy? In this case, it's even simpler. 10%, it just needs to be converted to a fractional form. So, 10%, I need to move the decimal point 2 to the left. So 0.1 is equal to 10. Or let's write it out. Well, 1 times 10 to the minus 1 equals 10 to the minus 1. And the point here is, this is the fraction. 10 to the minus 1 is equal to E, is equal to E to the minus X. For now, we'll just call that X. Equals 10 to the 0.434 to the minus X. So 10 to the minus 1, I'll just put that over here one more time, equals 10 to the minus 1. 10 to this is equal to that. Now I never even have to come out of the exponent. I can deal with, now I have a simple algebraic problem that is easily solved. So that means that X is equal to 1, or let me solve it this way. 0.434 times X is equal to 1, because the minus signs cancel. And that means X is equal to 1 divided by 0.434. And if it was any other number, I'd have to go out and do the division. But we easily recognize this because we've seen it before. It equals 2.303. The base of the natural logs. The exponent that the base of natural logs is raised to be equal to 10. So that means that 10% of the molecules have this. The X is equal to that, and therefore 10% of the molecules greater than or equal to 2.303 kVT. So we're always going to express these in terms of kVT. We just solve for that. But the neat trick here is, once we had it up in the exponent, to simplify the problem, all we had to do was solve for this. And then we were done. We found the multiple. So it's actually easier to find the fraction or the percentage than it is to go the other way. I could easily say what percent, and that involves a little more manipulation than going this way. But now that we've got all of this information, we can answer the last question. This is the what percent of the molecules. This is the 10% have have E less than that. E 10%. This is EK. This is 3 kVT. So we know that the E 10% was the what percent of molecules? This was the 2.303 kVT is less than or equal to EK is less than or equal to 3 kVT. So I just wanted to substitute in this E 10%. This is the 10% energy, greater than or equal to that. And so I want to know what fraction, and this fraction, this is 10%, and this is 5%. So it means that the percent of molecules with the energy in between these two is 10% minus 5% equals 5%. So 5% of the molecules, 5% have an energy greater than or equal to 3 kBt. And then 10% have an energy greater than or equal to 2.303 kBt. That means that 5% of the molecules have an energy between these two values. That's all. It's just another application.